In this video, I'm going over our review, which is over our rules of exponents. So we just have to remember here the product rule that when we are multiplying, if the bases are the same, so notice how the bases are all 4, then we would add the exponents together. So again, the product rule is that we are going to add the exponents, however, only if the bases are the same. So if the bases are not the same, then you don't add the exponents. So like, for example, in this case, if I were to add my exponents, you would get 4 squared, which is 16. And then the quotient rule. Well, if I'm dividing, we'll think of the opposite. Here, when multiplying, we added the exponents. So here, when we're dividing, we're going to subtract the exponents. But again, we're only going to subtract the exponents if the bases are the same. So again, notice how the bases are both 4. So again, if the bases are the same, we're going to subtract the exponents. And then keep in mind, we're going to subtract top to bottom. So this is 9 minus negative 12. So notice how here we have the two negatives making positive. So this is 4 to the 21st power. Then here we have talked about this in the past, but again, just a reminder, when you add a power to a power, when we had our two exponents here, right, power to a power, well, remember with the parentheses, what do we always do? We're going to multiply now. So we would multiply the exponents when you had a power raised to a power. So in this case, this would be 4 to the 45th power. Now, the negative, we hadn't talked about this in recent time. If you have a negative exponent, we can't leave a negative. So to make it positive, the exponent, we're going to take the reciprocal of the base. So here we're going to take the reciprocal of the base that's being raised to the negative exponent. Or remember, reciprocal just means we're going to flip it. So we're going to flip the base. So like here, for example, if I have 4 to the negative 12, well, 4 is my base. Or think about it like how it's 4 over 1. So what is the reciprocal, or how would 4 be flipped? Well, 4 would be flipped to 1 over 4, but raise that now to the positive 12 exponent. So we're going to flip, we're going to get the reciprocal of the base to make our exponent positive before you could simplify. So like here, for example, notice how we're multiplying, right? So if I'm multiplying, we are going to add the exponents. So here I've got now 4 to the negative 3 over 4 to the 5th. Now we have a quotient. We're dividing. So what do we now do with the exponents? Subtract them, top to bottom. So if you need to, write it out. So this is negative 3 minus 5, because again, the bases are the same. So this would make our new expression here 4 to the negative 8. However, can we leave this as is? No, because of the negative exponent here, we need to flip our base of 4. Well, what's the reciprocal of 4? 1 over 4 raised to the 8th power. So keep in mind, we are using and practicing these exponent rules here. So like in these first couple of examples, again, here we have a power to a power. So what did we always do with a power to a power? Think of the parenthesis, multiply. So this is now 3 to the negative 8. Now, are we done? No, because this is 3 to the negative 8. We don't want to leave a negative exponent. So what is the reciprocal of our base of 3? 1 over 3, then raised to the 8th power. So now here, notice how I have parentheses. So I'm going to first do what's inside the parentheses, think about order of operations. And because we're multiplying, remember what is our rule? Add the exponents. So now this becomes x to the negative 17 when you add negative 11 and negative 6, still raised to the second power. Now we have a power to a power again. So what do? Multiply them. So this becomes now x to the negative 34. Well, even if we have a variable as our base, we still have a negative exponent. So in order to make it positive, we're going to flip it. Well, if this is just x or x over 1, then what is the reciprocal? 1 over x to the 34th power. Now, we could simplify this even more, and I haven't done that before. So just to show you, they're both the numerator and denominator being raised to the 34th power. So 1 to the 34th, well, that's just 1 times 1 times 1. So that is still 1. So 1 over x to the 34th power. So now see here, notice how can we add the exponents in the numerator to make 17? No, because the bases are different. Notice how I have a base of 2 and a base of 4. We have a base of 2 and a base of 4. So what this means is only if the bases are the same can we follow any of our rules. Well, here I've got 2 and then 2 in the denominator. So that means we're going to subtract the exponents because we're dividing. So we're going to use our quotient rule. So this is 10 minus 12. Remember, top to bottom. So 10 minus 12, which is 2 to the negative 2 here. Then we're going to multiply that again. We have our bases, which are the same. So again, top to bottom. That's 7 minus 5, which is just 4 to the second power. Now I'm going to continue because we hear the 2 has a negative exponent. So we're going to flip or reciprocate the base. So the reciprocal of 2 is 1 over 2. So 1 over 2 being raised now to the second power, still being raised, still being multiplied to 4 to the second power. Now this is 1/2 times 1/2. That's 1 to the second power, which is 1, over 2 to the second power, which is 4, times 4 squared, which is 16. So really we have 1/4 times 16, which is 4. So go ahead and pause the video and try these 3 U tries on your own, and let's see what you get. With our first U try, notice how we can't add the exponents together, but we can use the quotient rule because the bases are the same here. So if they're both 6, remember, subtract. That's 8 minus 6. So now I've got 6 squared times, again, the bases are the same. Now keep in mind, this 3 has an exponent of 1, because that's just 3 to the first power. And again, subtract 1 minus 3. So now I've got 3 to the negative 2. Now here, our base of 3 has the negative exponent. So I'm going to, you should have brought down 6 squared, but now times, the reciprocal of 3 is 1 over 3 to the second power. Now I can start simplifying. Well, 6 squared is 36 times, we have 1 squared, which is 1, over 3 squared, which is 9. 36 times 1/9 is 4. Here you had power to a power, so what were you supposed to do? Multiply them. So this is y to the negative 15. But again, we have a negative exponent, so what's the reciprocal of y? 1 over y to the 15th power. Then you can simplify this more because that's 1 to the 15th, which is 1 over y to the 15th power. And last here, think of order of op. We have bases are the same. So again, because we're multiplying, we're going to add the exponents. So here you should have 8 to the negative 1. 2 plus negative 3 is negative 1, but still raised to the 4th power. So now there we have a power to a power, multiply. So this is 8 to the negative 4th. But because we have a negative 4 exponent, now make sure to get the reciprocal of 8, which is 1 over 8, now being raised to that positive 4th power. Now, if you wanted to, of course, remember here, guys, we can continue simplifying because this is 1 to the 4th, which is just 1 over 8 to the 4th, which is 4,096. Now, these are the examples that we're going to be getting to on Friday. So I would say don't we'll look at these just yet. Pause here, and then come back to this later on. So with our problems for Friday, notice how we're just bringing in fractions. So we have our rational exponents, but the rules still apply. Here I have a power to a power, so we're going to multiply. So when you multiply 4 times -1/2, you now have 3 to the -2 power. Then same as before, we can't leave a negative exponent, so we're going to flip our base, which is now 1/3 raised to the second power. Then simplify, 1 squared, 1/3 squared, which is 9. Then here, notice how the rules apply when multiplying. We're going to add the exponents. So we're going to add the exponents because the bases are the same. The bases are technically A, and A. Because the 6 here is a coefficient, times 2 is a coefficient, times 3 is a coefficient. So you still multiply the coefficients here, which gives you 36. Now all the bases were A, so we're going to keep our base of A, but then add the exponents. So like here, for example, you end up with 4/2 plus another 4/2, which is now 8/2. Well, technically 8/2, well, 8 divided by 2 is 4. So really, this is 36A to the 4th. Then C. Again, notice how we can't add the exponents because the bases are different. I have a base of 2 and a base of 5. But we have our quotient rule because the bases here are the same. So top to bottom, we're going to subtract. We have -1/2 minus 5 halves, 5/2. So this is now 2 to the -6/2. Then times, again, we have our bases are the same. So top to bottom, subtract. 3/2 minus -1/2. Notice 2 negatives making a positive. So this is now 5 to the 4/2. Now we can simplify this even further because this is 2 to the -3 from -6 divided by 2. And times, well, this is 5 squared from 4 divided by 2. But we're not done because we have a negative exponent here with our base of 2. So let's flip it. Reciprocal of 2 is 1/2 the third power times 5 squared. Now let's continue simplifying. Well, that's 1 to the third power, 1 times 1 times 1. So that's 1 to the third, which is still 1, over 2 to the third power. So again, 2 to the third power, which is now 2 times 2 times 2, which is 8, times 5 squared. Well, that's just 25. Now, when multiplying, you can't really divide evenly, so we're going to leave this as 25/8. So go ahead and pause the video and try these 3 U-tries on your own, and let's see how you do. So here with the first U-try, you had again a power to a power, so power to a power, multiply. So that is x to the -2. But you should not have left this negative exponent, so flip the base. The reciprocal of x is 1/x being raised to the second power, which of course you can continue on because that is 1 to the second power, which is still 1/x squared. Then here you have the bases, which technically are y. Y is being raised to this exponent. So all the bases are the same, so we can add the exponents. However, the coefficients of 3, 4, and -2, we're going to multiply. So they're just good old numbers, right? Coefficients. So when you multiply, you should have gotten -24. Now we're going to add the exponents. Well, 2/3 plus -1/3 is 1/3 plus 5/3. So you have the 1/3 plus the 5/3, which is now y to the 6/3. Well, here you can simplify that into negative 24 y to the second power, because that's 6 divided by 3. Now, some of you wanted to say, well, aren't we supposed to also then reciprocate or flip the base? No, because the exponent is positive. Remember, this is exponent rules. That's a coefficient of negative 24. So this is our final answer, because negative 24 is just our value here, not the exponent. So then the last one, again, bases have to be the same in order to follow the rules. So notice how we do have these two bases of 3. We're going to use our quotient rule because we're dividing. We're going to subtract top to bottom. Negative 3/4 minus negative 7/4. So if you notice, if you need to, write it out. Now, if you notice, you should have gotten 2 negatives, which make a positive. So this is 3 to the 4/4. Then times, again, you have bases are the same, 8/8. So top to bottom, subtract again. 1/5 minus 6/5, which gives you 8 to the negative 5/5. Now, of course, if you notice, we could still simplify that, right? Because 4 divided by 4 is 1. So that's just 3 to the first power times. Here you have 8 to the negative 5 divided by 5, which is negative 1. Now notice 8 here, the base has an exponent of negative 1. So we need to flip. So I've got 3 to the first times 1/8 to the first. Well, really anything to the first power is still that base. So really this is 3 times 1/8. So we're going to leave this as 3